My name is Alexa, and I'm working with Legia, and we are doing the Lake Ontario Driver Stewardship Initiative. So today, we are gonna focus on the ecological importance of Lake Ontario and how the invasive mussels will are going to continue to threaten the long-term health. Throughout this presentation, we'll explain what we learned from the 15 previous research projects and how these findings integrated and shaped our management plan we designed for this assignment. We'll also walk you through a timeline, a proposed solution, and professional roles that we took on. Each of us contributed at different parts of this plan, and together it forms a well-rounded approach to the mussel problem in Lake Ontario. You go then. Okay. So what is wrong with quagga mussels? So these quagga mussels are one of the most harmful invasive species in the entire Great Lakes. They spread super fast and they attach to almost any underwater surface, forming dense colonies at the lake bottoms. These colonies outcompete native mussels and they disrupt entire ecosystems. They can clog water intake pipes, damage infrastructure, and filter out huge amounts of plankton, which affects the food web from the bottom up. They also harm the native biodiversity and cause economic damage by attaching to boats, beaches, and multiple types of equipment. All of these effects make them major environmental and economic threats towards the Great Lakes.
So our target area is the Braddock Bay, which lies within the Rochester embayment. And this was an area that was previously an AOC, but it was officially delisted as an area of concern back in October 2024 after more than $14 million was spent towards cleanup, habitat restoration, and rebuilding the benthic communities. There's a new sewer system, restored wetlands, and returning wildlife, which have all transformed the embayment into what Monroe County Executive Adam Bello calls a thriving ecosystem once again. With that much effort poured into recovery, it would be devastating to let quagga mussels undermine the progress that local, state, and federal partners fought for. So on this next slide, you can see our target area here is outlined in red. It sits about 1 mile off the coast of Braddock Bay in the nearshore waters. This region has the right conditions for quagga mussels, and when we overlap the red boundary with Lake Ontario quagga mussel density map here on the left, it clearly falls within a moderate density zone where it's low enough for manageable removal, yet high enough to signal a real risk to the bay if left unchecked.
So for my 5 projects, the first one being the Great Lakes Mussel Collaborative. They showed a lot of value with coordinated surveys and shared data, which is super essential for detecting the early signs of these mussels. The next one will be the New York State Aquatic Invasive Species Task Force. This shows the statewide approach and that helps prevent the spread of invasive species and it strengthens the long-term management. The third one is the Western TEK program. They highlighted how Indigenous ecological knowledge provides long-term insight into species and behavior for ecological changes. The fourth one is the Great Lakes Restoration Initiative, or the GLRI. They emphasize how federal funding speeds up restoration and improves regional coordination. So they're more on the federal funding side. And the last one is the Sea Lamprey Control Program. They showed us that targeted removal and consistent monitoring can be pretty successful, and they can help reduce these invasive populations.
Before I move on, I do want to encourage everyone to pause on this slide and the next, and feel free to skip back to Alexa's projects to read through each of the projects we reviewed. As Alexa previously mentioned, we drew from more than 15 different studies, programs, monitoring efforts, and news articles to shape our pilot program. Instead of walking through each one, I do want to highlight the main themes that guided our model and timeline. So the first theme is ecosystem impact. Across research, quagga mussels consistently reshape benthic communities. They shift the nutrient patterns and also alter food webs. These changes reinforce the urgency of early intervention before ecosystems reach a tipping point. The second theme is monitoring and mapping. Many projects emphasize how critical it is to understand the spatial patterns where mussels are establishing, how density changes across depth, and which areas are most vulnerable. That kind of spatial insight helps us prioritize where action will make the greatest difference. The third theme is evaluating treatment methods. We saw that chemical options carry ecological risks and unpredicted outcomes in open water systems. So, because of that, this pushed us towards non-chemical diver-based methods that are safer and more targeted. And the fourth theme is a hands-on management and collaboration. It's a clear takeaway that real progress happens when science, tribal knowledge, and community partners work together. The one project I'll name here is the Sea Grant California program because they already developed a detailed diver protocols for the quagga mussel removal. We use those protocols as the foundation for our own removal methods as well. So all these themes helped us design a pilot program that is that is practical, culturally grounded, and ecologically safe, and is scalable. So with that being said, we're going to move on into our proposed solution. And that is the Lake Ontario Diver Stewardship Initiative, or LODSI, which centers on three connected goals. The first is creating a Lake Ontario Diver Corps. Our goal is to integrate Western science with tech and offer paid positions for Indigenous divers and invite volunteers and and invite volunteers and universities to take part in the diving program. So that's all of us working together to protect the lakes from invasive species. The second goal here is protecting a vulnerable nearshore ecosystem. So, as we previously mentioned, Braddock Bay was just restored, and with climate change extending quagga mussel growing seasons and reducing winter die-offs, we do need an adaptive, forward-thinking approach to keep this early action zone safe from infestation. And third, building a pilot model for basin-wide restoration. This is a 40-acre site, and it becomes a place where things like education, community, and action can come together. With recreational use projected to rise due to the delisting of the Bayman area, prevention and monitoring must begin now. This initiative raises awareness about invasive species, and it also establishes a stewardship program designed to stay and grow within the needs of the lake. So, what's the game plan? First things first, I do want to mention that our game plan includes 7 program characteristics that move this project from training to long-term community involvement. So the very first step is establishing a solid training and education program. Our first 10 divers and volunteers will complete online courses in the off season and then hands-on training from July through September. We want everyone to know what they're doing, why it matters, and how to stay safe during the process. The next aspect of this project is to organize a team. And what that means is we build a diverse team with a wide range of skills to support our 10 paid divers and any qualified volunteer divers who join the program. That mix of perspectives and expertise is the backbone of this project, and it's what's going to make it work. Next, the pre-removal survey. So that's where we map the site, take before photos and videos, and collect baseline water and benthic samples so we can measure meaningful change and use our time wisely. The fourth aspect focuses on the actual removal process, and that's when divers head straight into the target area and begin to manually collect the quagga mussels. It's physical, detail-oriented work, but it's part of the project that truly drives restoration forward. Afterwards, we focus on disposal and post-removal surveys. So disposal could mean, we freeze and safely dispose of the collected mussels, and then we repeat our sampling and visuals to track any change that occurred after removing the quagga mussels. Now, in order for this project to be successful, we must engage the community. So that means volunteers help with events. We promote the clean, drain, and dry campaign. And we launch, and this is a big theme in our project as well, is launching a university innovation challenge focused on improving manual, non-chemical removal methods and expanding research on effective mussel population reduction. Finally, to ensure continued success, we do need to evaluate the program needs. So that means we review, the strengths, the weaknesses, we consider climate change impacts, we discuss improvements with tribal and community partners, and plan ahead for the next season. And that way, with these 7 steps and aspects in mind, it helps keep the project accountable. It's an adaptive strategy and framework and it allows for growth year after year as well. Now, before I pass the baton back over to my colleague Alexa, I do want to show you the manual mussel collection strategies. So on this side, you can see the handheld tools our divers would use in the field. So we rely on simple tools like scrapers, knives, and mesh bags for quick collection in tight and delicate spaces. And then on the left is a small suction pump designed for underwater use, which helps loosen and collect mussels without disturbing too much of the sediment. These tools are really lightweight, they're easy to use underwater, and they're perfect for fine scale removal work. And then on this next slide, we have here the Venturi style pump system. And this pump system creates a strong suction underwater that allows divers to vacuum quagga mussels straight off the lake bed. And how it works is the mussels and debris travel through the hose into a mesh bag where then the sediment drains out and the mussels are retained. This setup works best in the shallow to mid-depth water range and gives our team a powerful option when we're covering large-scale sections of the site.
So my role would be wildlife manager, and as a wildlife manager, I would be focused on understanding the mussel populations and how they behave in the lake. I would conduct population assessments to help identify depth ranges and hotspots where the mussels are mostly concentrated. I also will monitor the water quality and nutrition cycles that the mussels influence. One major part of my job would be to be involved in the ecological monitoring and surveys to help detect the mussels, especially in the super deeper areas where they are becoming more and more common. I would use a predictive modeling to estimate how the mussel populations are spreading under climate change scenarios and even adaptive management strategies that and we have designed adaptive management strategies that respond to these changes. So overall, my job will provide the ecological foundation for the entire project, where the mussels are, how they spread, and how they alter the ecosystems.
All right, and then as a water quality specialist, I will be in charge of monitoring nearshore conditions before, during, and after removal. So I'll focus on things like water turbidity, dissolved oxygen, temperature, nutrients, and overall water chemistry and composition. And this will help us understand how the ecosystem responds in real time to the mussel removals. I'll also make sure our removal techniques don't harm native species by tracking any chemical shifts in the water composition and coordinating with the wildlife manager, which is my colleague here, Alexa. A key part of my role is to work with indigenous divers and knowledge holders in the indigenous communities. That way, we can compare scientific measurements with their ecological observations, so our approach stays inclusive and grounded in both types of knowledge systems. I'll also coordinate with the divers and the GIS staff to create maps that visualize water quality changes across the site. And then I would also provide any sort of guidance for adaptive management. So that would mean things like recommending when we should pause, adjust, or move forward based on what the lake conditions show.
So our both of our jobs and roles connect very, very closely. And as a wildlife manager, I would rely super heavily on the water quality specialist, which is my colleague Aligia, because the data, I would need to understand the data of why mussels are thriving in certain areas. So the water quality measurements, nutrient levels, clarity, and chemical changes help explain to me how the muscle behavior and growth are continuing, how they're trending. My ecological monitoring will help the Legia, the water quality specialist, because it'll understand how mussels affect water chemistry by combining our roles, we will create a stronger management approach for this project, and it'll connect biological patterns with chemical evidence, which is very helpful to guide decisions on the removal, prevention, and even long-term restoration. So working together will have a really good solution and more accurate results together. So for the limitations, Um, even with like a super strong solution, there are a lot of limitations that we are going to acknowledge. So one of those being the project targets adult mussels and not the drifting larva. This means that the larva from other areas could recognize the site over some time. Um, the our work will focus on the nearshore areas, which will avoid disturbance deeper, more sensitive habitats, but that means deeper populations may continue to persist. The weather and water conditions can slow down our diving operations, and equipment will fail because not everything is made perfectly. It'll interrupt our field work. So sediment disturbance during removal is another huge concern of ours, and training protocols and are very crucial. And checking if everyone is certified for everything before they get into the water is very crucial. This is all for protecting these native mussels and the habitats. You're muted again.
All right, let's talk about the budget now. Thank you, Alexa. For our budget, we broke the cost into three main categories down here under the cost analysis. But feel free to take a look at the individual categories of how we broke down the costs. But what I want to bring your attention to here is for the upfront costs and the first year operating costs, it comes to just over $2.1 million, which covers all equipment purchases, diver training, safety gear, and all the first full season of field operations. After that, the ongoing annual cost, which is mainly like personnel, fuel, the monitoring equipment, and things like maintenance, that could total to about 1.96 million per year. And so when we project this across the full program timeline, which is about a 5-year operating cost, that comes to roughly $10 million. And to make sure the program can adapt as needed, we built in a contingency fund of just under $1 million to cover unexpected expenses or additional needs that may come up as the conditions of the lake change.
So for the GLDO goals, the LODSI supports all three of the GLDO goals by removing the adult quagga mussels from the near shore, and it'll help protect water quality and maintain the progress already made in the Rochester embayment AOC, AOC. For our second, our diver core will reduce invasive mussels and build long-term capacity for this continued management, which will match the GLDO's focus on prevention and resilience. And third, our work protects sensitive nearshore habitat and native mussel beds from further degradation. This strengthens the shoreline ecosystems that are very valuable to climate change and invasive pressures. So overall, our entire project advances long-term restoration across Lake Ontario. And these are our references. Most of the links are clickable, but if they're not, they are copy and paste. Um, yeah, thank you for listening to our presentation. I guess you can email me or Lydia if you have any questions regarding the information in this presentation.
Thank you, everyone. We hope that you enjoyed it.